Here we are on page 13, where we are asked to find the zeros and then graph the following polynomials. All right, so we've got polynomials, we've got to find the zeros. That is what x's will make the y value 0. So on number 23, we're first going to find 0 equals, and then it's x minus 1, x plus 2, and x minus 3. You may be thinking, wow, wouldn't it be nice if we could factor that? Oh, wait! It is factored. Since it is all multiplying here up to 0, that's really nice. We could get an answer by making this one 0. So x minus 1 equals 0. That gives us x equals 1. That's an answer. So 1 will give us a 0. What if x is negative 2? Yep, indeed, negative 2 will give us a 0. And 3, x equals 3. So that means we have the 3 points 1, 0 right there. Negative 2, 0 right there, and positive 3, 0 right up there. Good, so that gives us 3 points on the graph. There's another one that's very easy, and that is, hey, let's stick in 0 for x. So we're finding f of 0, sticking 0 in for x, and when we stick a 0 here, and a 0 there, and a 0 there, it becomes f of 0 equals negative 1 times positive 2 times negative 3. So we just stuck 0 in for x. 0 minus 1 is negative 1. 0 plus 2 is 2. 0 minus 3 is a negative 3. And we multiply these out, and that equals a positive 6. So that gives us the point 0, 6 as a point on the graph. So that's somewhere up about right there. So we could technically go through and start sticking in other x points like x equals 5 and 2 and negative 3 and all sorts of things up here and see where we are, but this gives us an idea of what it looks like. We have to be coming from down here and hitting that point and then hitting that point and then going back up through that one and off to infinity that way. Now this could be coming up, we're not sure, it could be coming like that. We're not sure. It's a sketch of the graph, but we know it goes through that point. We're not sure what the top point is up there, but there's a sketch of the graph. Good. Okay, number 24, same type of thing. Let's find the zeros. So where 0 equals 2x minus 5, 3x plus 4, and times x minus 1. So we're multiplying to get 0. That means it's going to be very easy. We let the first one equal 0. 2x minus 5 equals 0. Add 5. 2x equals 5. Divide by 2. X equals 5 over 2. So 5 halves, 0. Yeah, that's one of the points. So we'll go over here to 5 halves. It's about 2.5 right there. Good. This one, same process. Let this factor equal 0, and we get subtract 4, we get 3x equals a negative 4. Divide by 3, we get x equals a negative 4 thirds. So we go negative 4 thirds, about 1 1/3 there. And then this guy, oh, that's a nice one. That's x equals 1. Gives us that guy right there. Okay, good. Now, let's see if we can get that nice, easy y-intercept as well. If we stick 0 in here, m of 0, that's a 0 there, a 0 there, and a 0 there. Then we get m of 0 will be, so this is going to give us 0 something, negative 5 times positive 4 times negative 1. Positive 20. Ooh, that's pretty tall, right up there somewhere. Okay, so that gives us enough to graph the polynomial. Let's do it. It's got to go up like this, and then it probably comes down through that guy, hits that guy, and up through there, and then heads off. Good deal. Alrighty, let's look at number 25. 25, f of x equals 2x cubed minus 13x squared plus 17x plus 12. Oh shoot, it's not in factored form, so we've got to do a little bit different here. Well, we certainly can. We do know that if we stick in 0, we'll get 12, so that's a nice easy one. 0 plus 0 plus 0 plus 12, 0, 12. That's a nice easy one. I'll put this off to the side here. We got, let's put it down here, 0, 12. Good deal. That's one of them that we got. However, we don't know what the other ones are. Now, if we were to factor this is what the rational zeros theorem is all about, is that if there are zeros and it came from something like this, they would have to go into 12. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. So yeah, if you were to break this up into these things, the factors, this end one, and this end one, would have to times up to this last guy, 12. Alrighty, or they could have a 2 in the front as well, and so it could be a plus or minus 1/2, plus or minus 2 halves we have is 1, plus or minus 3 halves, plus or minus 4 halves is 2, plus or minus 6 halves is 3, and plus or minus 12 halves is 6. So out of all the numbers in the entire universe, all the fractions, these are the only possible fractions or rational numbers that could be zeros of here. We don't know which ones are, but we've now eliminated billions and billions of numbers. And now we're going to use these to find the rest of them. So let's write this down and do synthetic division. So we're going to take and guess with, here's the coefficient 2, negative 13, 17, and 12. And let's set this up and let's try numbers in here. Let's see what they work. I'm going to try 1 just because doggone it, 1's easy. So we're going to try 1. So 2 comes straight down here. 1 times 2 is 2. Negative 13 plus 2 is negative 11. 1 times negative 11 is negative 11. 17 times plus negative 11 is 6. And 1 times 6 is 6. Does that get 0? Nope, that gets 18. This actually told us that f of 1 equals 18. If you want to stick that in, f of 1 is clear up here at 18. That didn't help us find a 0, but when we get no remainder, we'll be able to see that. All right, let's go backwards and take away that. 1 didn't work. How about negative 1? 2 comes down. Negative 1 times 2 is a negative 2. Those two add together to give you a negative 15. Negative 1 times negative 15 is a positive 15. Those add together to 32. Negative 1 times that is a negative 32, and you get negative 20. That actually says that f of negative 1 equals negative 20. Now, we didn't get a 0, but it tells you that negative 1 is clear down here. Can you see that there has to be 1? Let's try a negative 1/2. See if between there and there it crossed straight through. Negative 1/2. So this comes down as 2. That's a negative 1. That adds together to give you a negative 14. Negative 1 times that is a positive 7. 17 plus 7 is 24. Negative 1/2 times 24 is a negative 12. And that gives us 0. Shazam! So that does tell us that negative 1/2 is indeed a 0. Excellent. And the other thing that happened was where this guy right up here represented the coefficients on x cubed, x squared, x, and the constant. Now that we've divided a power out, this is now 2x squared minus 14x plus a 24. This is a quadratic. We can do this. We can solve this guy. Let's write him out. We pulled this guy out of the x cubed, but now we have 2x squared minus 14x plus 24 equals 0. Do we know how to solve this? Sure we do. Factor out a 2. X squared minus 7x plus a 12 equals 0. This guy factors into x minus 3 and x minus 4. Hey, look at that. We have x equals 3 and x equals 4. And that guy doesn't give us anything. So our zeros were negative 1/2, 3, and 4. Good deal. So it must look something like this. Hit that point, turn around and come back down to that one and that one. Boy, that was a little bit ski-wampus there. Not a true function, but yeah, that's kind of what it looks like there. Good deal. And it went through the 0, 12. Good. So this is how this is the game plan for these that don't come in factored form. We've got to narrow it down to certain items that we can possibly guess. Then we guess some until we find one. And when we find one, it is divided out. That's why it's called synthetic division. It divides it out so that now we can get it down to an x squared, and we know how to deal with those. Good deal. Okay, so number 26. This right here looks like it can be a plus or minus 1 over 1. So yeah, I hope it's one of those. So let's try our synthetic division again. Put the coefficients in. 1, minus 1, minus 1, 1. And all right, let's give it a shot. Let's try a positive 1. drop this guy down. 1 times 1 is 1. That guy goes to a 0. 1 times 0 is 0. Add that up and you get a negative 1. 1 times negative 1 is negative 1. And 0. Shazam! So we get 1, 0 is indeed right there. Good deal. So what do we have left? This used to be an x cubed. This is now an x squared. So this is x squared, no x's, minus 1. Can we solve this? Find that equal to 0? Sure we can. Oh, hey, look, that factors x plus 1, x minus 1 equals 0. So we get x equals a negative 1. And we get x equals 1 again. Look, it happened up here, and it happens right there. So this guy actually happens, I'm going to mark him again, twice. And the negative 1 is over here. All right, can we get that y-intercept? Yeah, stick in 0 for x. F of 0 equals 0 minus 0 minus 0 plus 1 is a plus 1. So f of 0 equals 1. So it's right up here. So now notice what happens when you have two of them like this. It goes down through one and up through the other. So if these two get closer and closer together so that they're on the same dot, it does this sort of a thing. You come up here like this, and then it comes down, and it goes down and back up in one point. So that it's tangent. It comes down and touches it because both of those zeros are at the exact same point. So that's what the graph will look like. Good. Let's try 27. On 27 here, it looks like we could do the rational zeros. We have to times up to 8, so it could be a plus or minus 1, plus or minus 2, plus or minus 4, and a plus or minus 8. And then any of these factors could be also over any of these factors. So we could have a plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, or plus or minus 8/3. So we only have, what is that, 16 possible numbers out of all infinity. It's pretty overwhelming when you see them. You're like, oh, do we really have to go through and try each one of those? Well, it's better than shooting in the dark. At least we have a limited number that we can look at. So let's draw our little box here and put these coefficients down. 3, negative 14, negative 18, 8. And let's try a few of them out. Let's see what we get. So I'll try one. I always do that one first because it looks like it'll be the easiest. So we go 3. That's a 3 up there. That adds to negative 11. Multiplies to negative 11. Adds to a negative 29. Multiply that up there, negative 29. And we get negative 21. Ooh, that's not a 0. But notice that at 1, f of 1 is negative 21. So that means we're way down here somewhere. Okay, good. Let's try something else. Maybe we should get our y-intercept. If we stick 0 in here, 0, 0, 0, there's 8. That's an easy one to get. So we're up here. Well, that tells us one thing. There's a 0 somewhere in there. Let's try 1/2. See if it happens to be a fraction that's in there. 3 comes down here. 1/2 times 3 is 3/2. Oh boy, we're starting to get fractions. This could be ugly. Negative 14, that's negative 28/2, so that's negative 25/2. This is not going well. So that would be negative 25/4. Yeah, we're not going to get to 8. So never mind. Let's try something else. That one looks like it's not going to go through exactly 1/2. It won't be a fraction there. It might be a non-fraction, irrational number. Let's see. Okay, let's try another one. Maybe 2 or negative 1. Let's try negative 1. 3, negative 3. That's negative 17. That's positive 17. It becomes a negative 1. Positive 1 adds to 9. So at negative 1, we're up at 9. So it's not necessarily anything that we're going to have a 0 in between 0 and negative 1. Let's try 2. Let's try a 2. So with the 2 in there, 3 comes down. Multiply, you get 6. Add that, you get a negative 8. Multiply that, you get a negative 16. Add that, you get a negative 34. That's a negative 68. Wow, that's negative 60. So at 2, we're still way down there. Didn't work. Let's try another one. Good thing this synthetic division goes quickly, or this could get really boring. Let's try a negative 2. See what happens there. 3, that's a negative 6, becomes a negative 20. Positive 40 when you multiply that. Add those together and we get a negative, what is that, 22? Nope, a positive 22. And we times that and we get a negative 44. And add that together and we get a negative 36, it looks like. So we're way down here somewhere. Oh, negative 2 puts us way down here, but negative 1 was up here. Maybe there's something in between there. Is there one that's between a negative 1 and a negative 2 that's a fraction? Let's try that guy right there. Ooh, let's see if he works. Let's try a negative 4/3. The only reason I'm guessing that one is because negative 1 was up here and negative 2 was way down here. So it's got to cross somewhere in between there. And it could be irrational, but if it's rational, negative 4/3 might work. 3 comes down. Negative 4/3 times 3 is a negative 4. Negative 14 and negative 4 is a negative 18. That times that is negative 4/3 times negative 18 is a positive 24. Negative 18 times plus a positive 24, that's a positive 6. Negative 4/3 times 6, I don't believe it. It's a negative 8. 0. Shazam! Look at that. So negative 4/3 is indeed a 0. If you stick in negative 4/3, you get 0 out. Good deal. Now we're left with, this was an x cubed. Let's write that up there. This was an x cubed. Yeah, now it's an x squared. So let's write this down. 3x squared minus 18x plus 6. Can we find the zeros to this? Well, let's get rid of, let's factor out a 3. So we get 3x squared minus 6x plus a 2 equals 0. Does that factor? I don't think so. X squared minus 6x plus 2. If it won't factor, we've got to use one of our other ways of solving quadratics. In this case, we can use completing the square. Yeah, completing the square. Half of negative 6 is negative 3. Squared, add 9 to both sides. Add 9 and add 9. And we now have, we've now completed it. This is now x minus 3 squared equals 7. Square root both sides, square root, plus or minus. We get x minus 3 equals plus or minus the square root of 7. And then x equals, add 3 to both sides, 3 plus or minus the square root of 7. So we found all three of them now. We have one fraction, so none of these other guys would have worked, and then 3 plus or minus the square root of 7. If I stick this into a calculator, we get 3 plus the square root of 7. Square root of 7 is like roughly 2.5 something. So it's up at like 5.5. 3 minus the square root of 7, that's 3 minus 2.5, so roughly 0.5 something. Yeah, oh, that's the one we thought was going to be 1/2, but it wasn't. It's an irrational number. Alrighty, we got them. Let's look and see what the graph looks like then. So it starts down here, and it goes up like this, and we'll come down here like that, and go right through that red point. You think I missed, but I didn't. Okay, right there. And that's what it looks like. And notice all these x cubed are looking pretty much similar with this wave going on. Oh, that was a long one. That was a tough one, but it gave us some irrational zeros to work on. All right, let's try number 28. Okay, let's get our y-intercept really easy. So if we stick in 0, that's going to be 0 minus 0 minus 0 equals 12. So 0, negative 12. Oh, that's kind of interesting. We're down here on the y-intercept. All right, let's find out what are the other options for x-intercepts. So that is, if we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus, oh, it's the list we had over on number 25, pretty close, 6 and plus or minus 12, and then plus or minus 1/2. So we had to take these over the factors of the 2. Plus or minus 1/2, plus or minus 2/2 we've already got, plus or minus 3/2. Okay, plus or minus 4/2 we've already got it with the 2, 6/2 is 3, and 12/2 is 6. So these are all of our options. All right, let's set up our synthetic division. So we're going to take the numbers and stick them into 2, negative 1, negative 25, and negative 12. And let's see what we get. All right, so I'm going to try 1 just because he's easy. 2 times 1 is 1. That's a 0. 0, that's a negative 25. Oh, that's not going to work. That's like a negative 37. So at 1, we're down here at negative 37. That's good to know that we're headed down right there. Let's go back. Try a negative 1. 2 times negative 1 is a negative 2. That becomes a negative 3 when we add it. Times that, and you get a positive 3. That becomes a negative 22. Negative 1 times negative 22 is a positive 22. And that becomes a positive 10. Ooh, so negative 1 is up here. All right, so there could be one right between, well, there is one. I just don't know if it's going to be a fraction or whether it'd be irrational like number 27, but let's give it a try with negative 1/2. That looks promising. So the 2 is here. Negative 1/2 times that is a negative 1. Add those two together and you get a negative 2. Times that and we get a positive 1. And so that becomes a negative 24 when we add them. And then that times that is a positive 12. Oh my word, look at that. Shazam! So negative 1/2 is one of them. And that reduced it down from an x cubed. Yeah, we had an x cubed. Now it's down to an x squared. So let's write that out. 2x squared minus 2x minus 24. And we've got to find the zeros of that. Okay, we can factor 2 out. We've got x squared minus x minus 12. Does that factor, or are we going to have to do completing the square or something? I think that factors. Yeah, what times is to a negative 12 and adds to a negative 1? That's minus 4 and a positive 3. Equals 0. And so we get x equals 4 and x equals a negative 3. So negative 3 back here and positive 4 way up there. All right, let's graph it, see what she looks like. So this is the last one, so we've got to be coming up like this, and we're going to come down like that, guys. And then he turns around at some point and has to go back up through that guy. Of course, on your calculator, this will come out with much straighter lines than what I've drawn, but that's what he looks like. Excellent.